In this video, and it will effectively be a short one, we are discussing the properties of the duration measure, and it's just the relationship between duration and various bond parameters like the coupon, the time to maturity, the yield to maturity, etc. Given that we have already discussed a lot of these things, shouldn't be that difficult in this video. So I'm just going to open up and show you a lesson from a previous video that we did on the relationship between bond parameters and its riskiness. Okay, here's the promised note from that video, relationship between bond prices and bond futures. And look, back then we talked about the coupon effect. We also talked about the maturity effect, for example, shorter maturities meaning less sensitivity to yield changes. So I'm going to keep this on the side here as we discuss our relationship of bond futures and duration. Let's say that all of these are true, all else being equal. So with the assumption you're not changing out any of the other parameters, these will hold true. Let's start with the coupon. Well, as I said, in that previous lesson some time ago, we said that depending on how big the coupon is, bonds will show different sensitivities to yield changes, and generally speaking, a higher coupon means less sensitivity to interest rate changes, because a higher coupon means the bond has lower duration because more money gets received earlier. That's the logic. So that translates into Macaulay duration, the weighted time to the receipt of the coupons. Higher coupon means lower duration and less sensitivity to interest rate changes. So the nature of the relationship between coupon size and duration is going to be an inverse relationship. Right, that's the first parameter tackled. Now for the YTM, the yield to maturity. Well, I like to think about this one, or of this one, as a function of this chart that I keep drawing, where on the one hand you've got the bond price, on the other hand you've got the yield, and the convex curve. And because duration, especially when you think about it in terms of the modified duration, is the slope of that curve, depending on where we are on the yield axis, you get either higher or lower durations, but they are very high when you have low yields. And a higher yield is going to give you a flatter slope, so higher YTM leads to lower duration. And you can also think about this in another way, because when you compute Macaulay duration, you have to discount the future cash flows to compute their present values. Effectively, having a very high yield gives you a lower discounted value. So you may also think of that way mathematically, but I think it's easier to think of in terms of that slope on different points of the curve. So once again, the relationship is going to be an inverse one over here. Now, the next parameter is the time to maturity. And as we know from previous learnings, you know this as well, bonds with longer maturities have generally a longer time, weighted average time to the receipt of the money. So typically you see longer time to maturity, resulting in higher duration. So this is where, instead of having an inverse relationship, we're going to have a direct or simply a positive relationship. Longer time means longer duration. However, let me say that this is typically, because there is an exception to this rule, and it's an exception we already talked about in that previous video some time ago, where I talked about the maturity effect, and we did write longer maturity, more sensitivity, so higher duration. There was a small exception which I talked about over here for long-term bonds with low coupons but not zero, trading at a discount. Well, let me just copy this from my previous note. Right, copy, hopefully, yeah, and paste this into my current note as well. Let's see if it works. Will it copy? I have to plug my keyboard in for it to actually effectively copy. Anyway, that's the little exception. If you have a bond, a long-term bond with low coupons but not zero, trading at a discount, you may see that a longer maturity does not necessarily give, a longer time to maturity does not necessarily result in a higher duration. But that's an exception just to know about. I don't know, low chance of being tested, but still. And the final little bit of parameter is the fraction of current coupon period which has elapsed. So that's T over T. Little t is the time since the last coupon, and big T, capital T, is the overall number of days in the coupon period as such. And as you know, as we approach the coupon payment date, which is also the reset date for floating rate notes, and this, by the way, this is pretty much applicable for FRNs, right? As we go this way on the time scale, we get closer to the coupon reset or the MRR reset. And we said in the previous recording that I did that duration is a measure of generally the time left, and as there is less time left in the coupon period, we get lower and lower duration. So here the same thing. The more time has already elapsed, so time t in relation, small t, in relation to capital T, the overall period, number of days in the coupon period, as this gets bigger and bigger and bigger, as this little t increases, or the whole fraction increases, we get lower duration, less risk. So the relationship is going to be once again n in verse 1. As t, little t over capital T grows, we get less duration, less sensitivity to interest rate changes.